life, food, and life. I want to say thank you and bless us for what we are going to do here. Lord, may you be with us. Give us the ears of listening so that we can have that knowledge of answering the papers. In Jesus' name I pray. Bye.
Okay, thank you so much for the word of prayer, Malera Kabara CDSS, and we want to thank all the schools that have joined. Thank you so much for keeping time. We are starting, and I'm very happy to have the facilitator already on. Teacher Arthur, you are most welcome. Thank you so much for joining. Teacher Arthur, kindly take over.
Okay, thank you so much, Mr. Kaziba. So good afternoon. You can hear me loud and clear? Okay. So if you can hear me loud and clear, kindly wave. The schools that are listening in, am I loud and clear? If you can hear me, please kindly wave. Wave at the camera of the device you're using. Mamba Secondary, can you hear me? Okay. Malera Kabarua Seed, can you hear me? Okay, so it means I'm loud and clear. Let me also find out from others. Okay, so I hope that I'm very loud and clear. So I think we can start our today's session. Okay, that is great. Okay. So I hope my screen is coming through as well. Okay, so for purposes of clarity, I'm going to remove my video. Okay, so my name is Teacher Arthur Kugonza, and I'm teaching biology at St. Mary's College, Chisubi. So I send greetings from Chisubi. So today we're going to be going through the practicals. I'm sure yesterday in one of our sessions, you were taken through the theory exhaustively. So they're going to go through the practicals. So under the practicals, we are going to focus on the following. We shall look at the areas of a practical paper. In other words, what are the different groupings that we have when we are looking at, when we are doing or going to, or when we are preparing for a practical paper. Then we shall also look at the areas from which the first item comes from. By items, I'm meaning the questions. So we shall look at the areas from which item number ones come from. Then, of course, we shall use some samples. So we shall be using samples of the scenarios to see how best we can interpret practical items and how to respond to them. Then we shall also look at the report format. We shall discover that practicals have to be written or recorded in practical format. So we shall see that practical format. Then we shall also look at the detailed features of the report. Then we shall look at how scoring is done of item number 1. Then when we finish item number 1, we shall look at the areas from which item number 2 normally comes from or is likely to come from. Then we shall also look at some sample items of item number 2. And also we shall look at the basics of how scoring is done, so that as we are responding to our exams, we know how we are going to be scored. So that is basically what we are going to look at. Now, to start straight away, we shall start now with the real now practical area. Now, when we talk of practicals, the standard paper of a biology practical will be comprising of 2 items. It will be having item number 1, number 2. And when we talk of item number 1 is mainly about scientific investigation skills, or sometimes we call them scientific inquiry or processing skills. In other words, in this item, you are tested on whether, if given a task that requires an investigation, are you able to carry out an investigation and record or report your findings in a standard way that is accepted globally? So that is what item number 1 is all about. So it means that you'll be required to design and perform an experiment. But this experiment is aiming at solving a given problem or a given task that will be given in the scenario. Then item number 2 is about appreciating the structure and function in living organisms. So appreciating structure and function in living organisms. So we shall see what are the areas from which this item number 2 comes from. And when we say appreciating structure and function, what do we mean? How can we appreciate structure and function of these living organisms? So we shall look at all that. So basically, that is the composition of practical biology practicals. 2 items, and all items are compulsory. All items are compulsory. So to start off with our item number 1. So what is this item number 1? Now, item number 1 mainly, it targets mainly physiology and physical experiments. So it is about physiology. When we talk of physiology, we are basically meaning reactions that we have in biology. So it means that under this number, you're going to be playing with either chemicals. You're going to be playing with chemicals. If not chemicals, at least something. There should be some measuring or some measurement or some mixing of things. So that is what that item number 1 is all about. And these are the areas that it targets. These numbers or items will always come from either food tests. I want to believe that maybe your teachers have taken you through food tests at school. And that was a topic that was covered in senior 2 nutrition. Then they can also come from enzyme activity experiments. Still in senior 2, under the topic of enzymes, your teachers must have taken you through some of these experiments. The enzymes, maybe the enzyme catalase, etc., factors that affect enzyme activities, factors like pH and factors like temperature. So it can be about those enzymes. And specifically, if it is about enzymes, it is investigating only 2 factors, that is pH and the temperature. So they can give you a scenario whereby you have to design an experiment to find out what is the effect of pH on a given enzyme reaction, or how does temperature affect the activity of a given enzyme. Then they can also come from soil experiments. So the soil experiments, other soil experiments, we are now talking about drainage. It can be maybe about investigating drainage. It can be about capillarity. It can be about retention. It can be about content of water in a given soil sample under the soil experiments. And still, this is also a senior 2 topic, soil. Then it can also, the items or the questions from this number 1 can also come from the areas of osmosis. Now, osmosis must have been covered under transport in plants. I'm also sure that still in senior 2, that is the 3rd term, normal progress, your teachers must have taken you through osmosis experiments. Must have taken you through osmosis experiments under the topic of transport in plants. So these are the 4 areas from which number 1 can come from. As you can see, all these areas are coming from the topics. Sorry, someone is saying that my volume is very low. Okay, let me bring the laptop closer to me. Okay, so all these areas, as you can see, are coming from topics that you covered in either senior 2 or senior 3. All of these. So it means that by the time you completed the senior 3, to go to senior 4, we expect you to have finished all practicals, especially item number 1. So they are only coming from 3 topics. There is nutrition in animals, or maybe nutrient compounds. So nutrition in animals. Then we have nutrient compounds. Then we have soil, and then we have transport in plants. So these are the areas from which practical number 1 will come from. So what about this practical number 1 that is investigating scientific inquiry skills? Now, for us to understand these things better, I'm going to use samples, sample items, or sample questions. Now, when you look at this item that is being displayed on your screens, this is now a typical example of an item that can come in your exam. I'm not saying that you're going to find these items here, these exact ones, but these are now the samples. So they will give you an item like this one. So let us read through it to try to comprehend and understand what is before us. So they are saying that a farmer would like to plant rice. He has 2 plots of land that he has identified, from which he wants to choose which one to use. Rice grows mostly well in waterlogged soils. You are provided with soil sample A and B collected from the 2 plots. So this is our scenario. And mind you, all of these scenarios will be things that you're used to. Things that you witness them in the community, or things that you always maybe go through at school, or maybe things that you have ever heard of. So nothing is out of context to you. Then now let us now first analyze this scenario here, and we get to understand what is the problem here that we have to solve. And mind you, whenever you're given these scenarios, don't aim at looking at the task. First ask yourself, what is the problem that they want me to solve here? So what is at stake here? A farmer wants to plant rice. Maybe some of you come from communities that do plant rice. So they're saying now that the farmer who is stuck here, he has his 2 plots of land, but he only wants to use 1 plot of land. Only one, but he's not sure which plot would give him better yields when he grows his rice. He's not sure which plot, but at least he has some knowledge. He knows that rice grows well in waterlogged soils. So is knowing that rice grows well in waterlogged soils. Now, as a scientist, as a scientist, or maybe as someone who has learned biology from school, a farmer is approaching you. And he's approaching you, he's not taking you to his plots of land. No. This farmer also had some knowledge. So he went to his 2 plots, picked soil from plot A, picked soil from plot B. Now he's bringing it to you, these 2 soil samples, and he wants you to guide him as per the task. What the task is saying that he carry out a scientific investigation, to recommend the best plot for the farmer. So they now want you to use those 2 soil samples to design an experiment, and then you carry it out. Then out of those 2 plots, you have to choose which one is good or which one would be good for supporting the farmer's rice. Bearing in mind that you know that rice grows well in waterlogged soils. So this is now the task that is before us. They want us to carry out a scientific investigation to recommend the best plot for the farmer. And this is how you find your question, just plain and simple like that. Now, how do you respond? How do you respond? Now, the responding, you must respond in a known scientific way. And for us in biology, we are calling it now a report. And what are the features of this report? Or what is the template of this report that you should follow? Be able to design, carry out the experiment, and recommend the farmer the best plot for growing rice. So, ladies and gentlemen, this one you're seeing here in yellow is the report format with which you have to use to respond when answering such an item. So what are those features of a report? When you're coming up with a report, the first thing that you have to think about, or the first thing that you have to write, should be your aim. Then after the aim, you write the hypothesis. After the hypothesis, you write the variables. After the variables, you write materials and apparatus. After the materials and apparatus, you write the procedures. After the procedures, you write observations or the results that you'd have got. Then after that, you write the explanation of the results, or maybe you explain your results, or you interpret your results. Then after doing all that, you conclude. And you conclude and therefore give recommendations. So this is how the report format looks like. Now we're going to see, when we talk of the aim, what do we mean by the aim? To start off with that, when they talk of the aim is basically, an aim basically highlights what we intended to do. That is what the aim highlights, what we intended to do, the aim. In other words, when I read your aim, I should be able to get an idea of what you intended to do. And I must also be able to even get an idea of the kind of apparatus that you are going to use. The aim, some of you maybe is only always referred to as the title, but we don't refer it to as the title. So actually the aim is the title, but you're not going to record it as the title, but you're going to record it as the aim. In other words, what is the aim of you carrying out the experiment? Which experiment are you going to carry out, and what is its aim? What are you aiming at achieving? That is the aim or the title. So when we look at our scenario, this scenario that we have, what do you think is the appropriate aim here? What do you think is the appropriate aim when you look at this task that is a mid-task, or this scenario that is on your screens? So I need 1 or 2 volunteers or schools to come and tell us what do they think, or what do you think would be the best aim for such a scenario? Over to you. Who is ready? What do you think is the appropriate aim there? So Hill City College, unmute and give us your aim.
It is the aim is an experiment to investigate the best plot for growing rice.
So an experiment to investigate the best plot for growing rice. Okay, I've got it. Then now this one has not used the actual name. Please, okay, maybe someone using the account with Fabals. You can unmute. First, you first tell us your name, or the name of the school. Then you give us your aim. Someone using the account of Fabal. Okay. Maybe let us now hear from Malera Kabarwa Seed. Malera Kabarwa Seed. What do you think is the appropriate aim there?
The experiment is investigating on the structure, capillarity, and retention of soil that is suitable for growth.
Okay, structure, capillarity, retention
of the soil suitable for growing of crops. I mean rice.
Suitable
rice
for growing rice.
Rice growing.
Okay.
Yes.
Then one last one. Thank you. One last one. Solid rock. Solid rock Arua. Solid rock Arua.
Yes. Are you getting? No.
Yes, very clear and loud.
Yeah. The aim of the experiment is a scientific investigation to determine the best plot that the farmer should use for growing the crop of rice, actually.
Okay, thank you.
Yeah, welcome.
Your colleagues are congratulating you over there. Okay, fine. Okay. Okay, the hands are still up. Let me invite just one more. Okay, so one more. Let me see regional balance. Which one should I pick? Okay, let us pick someone from Nebi. Mamba Secondary, Nebi. Mamba Secondary, Nebi, unmute, and you give us your aim.
Yes. An experiment to investigate on the best soil sample for growing rice.
Okay, the best soil sample for growing rice. Okay, thank you. Okay, so I think these ones are enough. Let us first go with these ones here. Okay, now we have about 4 aims here which have been given. The first school was saying the best plot, an experiment to investigate the best plot for growing rice. Let us maybe start with that one. Now, we said that the aim, first of all, is like the title. And this aim is highlighting, the aim should be at least highlighting something that you intended to do or to carry out. That's what we call an aim. It highlights what you intended to do or carry out. And from your aim, I should also be able to detect the kind of experiments that you are going to use, or the kind of the materials that you're going to use. Now, if you say that the aim or the title is to investigate the best plot for growing rice, the question would be, how are you going to do it? How are you going to investigate the best plot for growing rice? If you can answer that question, then you are giving us the aim of your experiment. I hope I'm clear. If you say that the aim is to investigate the best plot for growing rice, now the question still is, how are you going to do it? How can you know the best plot for growing rice? Do we have materials in the lab that we can use to show us the best plots for growing rice? I don't think that we have them. We don't have them. Have we been taught experiments at school, experiments of choosing the best plots for growing rice? No, they haven't taught us those experiments. So it means that if you say the aim of the best plot for growing rice, and actually 3 of the aims that I have got are on that. All of you, you want to investigate the best plot for growing rice, but still the question is, how are you going to do it? How are you going to do it? Then, Cedar Hill School, they're telling us that an experiment to investigate structure, capillarity, retention. And now those are very many things. What exactly are you going to carry out? If you investigate structure, why are you investigating the structure? If you want to investigate the capillarity, why the capillarity? Retention, why the retention? So that is too much. It means we're going to do 3 experiments. The first experiment, soil structure. The second experiment, capillarity. The third experiment, retention. So how exactly are you going to do all of these experiments? And how will you conclude that actually one of these plots is good for growing rice? So Cedar Hill, you are almost there, but you're now bringing so many experiments. You have to focus. In other words, your aim should be focused on one thing that you intended to do. So I want now one school to give us what they think is the correct aim. I don't want responses like to investigate the best plot for growing rice, if that is the case, but how are you going to do it? What are you going to do to know that this soil sample can support rice growing? All together? Then, okay, let me also, okay, let me now give the chance to Kangole girls. Kangole girls, you can unmute and give us your aim. Kangole, we are not hearing you. Okay. Okay. Let us hear now from Ushindi SS. Ushindi SS. Ushindi, you can unmute and give us the aim of this experiment. People are unmuting, but I can't hear them. Is it a problem with the network, mine, or? Okay, Patong Seed Secondary School. Unmute and we see if we can hear you. Patong Seed.
An experiment to investigate water retention on the best type of soil so that the farmer can use for growing rice.
Aha. Yes, thank you. That one is coming from Ushindi. So Ushindi, they are telling us that it is an experiment to investigate water retention of the soil samples to choose which one can support or which one is good for the farmer to grow his rice. So we are hearing the word that to investigate water retention. Now, are there any questions that how are you going to do it? How are you going to investigate retention? That one is very clear. We have apparatus or we have procedures in biology that we can follow to find out the water retention. So that one would pass for an aim. Why? Because it is focused. They know what they want to do and how to do it. They want to find out water retention capacity of the two soil samples. Then basing on that, they are able to recommend the best plot for growing rice. So I think for the interest of time, now the aim here, we can have two options. One person can choose to investigate, to compare water retention, knowing that the soil sample which would be having the better retention, which will be having a high retention capacity. It means that that is the soil that can easily be waterlogged, hence good for growing rice. Then another person can choose to go for drainage. Drainage can also be done here. You can carry out an experiment on drainage. In that, the soil which drains faster, that will now be, it means that now that soil cannot be waterlogged, hence can't support rice growing. So that one would be an appropriate aim. So it would be an experiment to compare, maybe an experiment to compare water retention of soil samples A and B, or an experiment to compare water drainage of soil samples A and B. So that one is the aim. I hope it is very clear. Oh, okay. So let me first check inbox. Inbox. Rate of water retention. Yes, Universal College Mubende. Yes, an experiment to determine the rate of water retention capacity. Yes, we can. That one can pass. Okay, pH. Someone is now saying to determine pH. Now, in this experiment, do we really have to look for pH? Because mind you, the clue that we have in our scenario is that rice grows in waterlogged soils. So it means indirectly, we want to find out of the two soil samples, which of the two soil samples can easily be waterlogged. Now, how will you use pH to find out which soil can be waterlogged? Is it that acidic soils are more waterlogged? Is it that the alkaline soils are more waterlogged? So that one may not apply here in this scenario here, because the information, better always pay attention to the words used in the scenarios. They have all the clues. They have all the clues. So you cannot carry out an experiment on pH to find out or to know whether a given soil sample can easily be waterlogged or not. Water retention, water holding capacity, water retention, yes. So they are about water retention. Okay, Nawandala SS in Iganga district. They are sending greetings to all of us. Thank you, Nawanda SS Iganga. Okay. So I hope now the debate of the aim is clear. In this case here, we are going to investigate water retention or water drainage. And you don't investigate two, just one is enough. As long as you're able now to know to link it with the water logging, Then the second feature of a report is the hypothesis. The second feature of a report is the hypothesis. So what is the hypothesis? I have some hands here. I think they want to ask. Okay, let me give them a chance in the hands up now. Okay. Yes, Mamba, you have a question?
We want to give answer for the hypothesis and how we think the hypothesis could be rice mostly grow well in waterlogged soils.
So your hypothesis is rice mostly grows well in waterlogged soils. Thank you. Kangole seed, you can unmute. Kangole girls SS.
No.
Yes, we can hear you.
Okay, the hypothesis is the soil sample that retains water for a long time is the best soil for growing rice.
The soil sample that retains water for long is the best for growing.
The soil sample that retains water for a long time is the best soil for growing rice.
Okay, the water that retains water for a long time is the one which is good for growing rice. Okay, thank you. Skyland Lira. Skyland Lira. Skyland Lira, are you there? Okay, then, okay, lastly, Onono Memorial. Onono Memorial.
The soil sample that drains water slowly is the best soil for growing rice.
Okay, the soil sample that drains water slowly is the best for growing rice. Okay, thank you. Now, let us use those ones. Then we get to understand what a hypothesis is. Let me first hide these other things. Okay, just a moment. This one. Okay, so what is the hypothesis? A hypothesis is simply a prediction of the outcomes. And this prediction is stemming from your aim. So the aim and the hypothesis must somehow be connected. They must somehow be linked together. If we said that if my aim was to compare, water retention of soil samples, A and B. If that was my aim, compare water retention of soil samples A and B. Now, what would be the hypothesis there? hypothesis is simply a prediction of what you intend to get, or a prediction of the outcomes. But you don't just predict wildly, that you don't just guess for the sake of guessing. Your prediction must be backed up with some reasoning, with a reason. This reason can either be theoretical from the theory that you have learned in schools, or it can be based on some evidence that you're seeing in the scenario. If you to say, for example, that rice mostly grows well in waterlogged soils, what reason are you giving? And how is it connected to your aim? How is it connected to the aim? So when you're stating a hypothesis, you have to be mindful of all those. We need to know, we need to see the connection of your prediction to the aim of the experiment, and with the reason why you think like that. Now here we have two soil samples, A and B, and you want to compare the water retention capacity of these two soil samples. Now the question is, what would be the hypothesis? What do you predict? What is your prediction with these two soil samples? And mind you, in life, we always do carry out some predictions in life. There is nothing that you can do without first thinking of the outcomes. Then it is that you base on to go on, carry out whatever you wanted to carry out, and afterwards evaluate it basing on how you had expected it to come out. So I'll give chance to two schools. Basing on what I have now told you, what do you think is the correct hypothesis to such a scenario? And my aim is to compare water retention of soil samples A and B. And then we are saying that, of course, we are not having these two soil samples A and B with us. It can be any. You just choose randomly. It is either soil sample A or soil sample B, whichever. Me, I want to see the reason that you are giving. So what is the prediction? What do you think would be the prediction? And I want you to attach a reason to your prediction. Okay. Let me first go in inbox, then I'll come to you. Okay, there is a reminder, please, if you are logged in as a school, if you're logged in as a school, you can kindly go to the feature of participants. Then there you're able to tap and rename yourself. So you rename yourself, you put there the name of the school and not the name of your account. Okay, so take note of that. Okay. Let me look through now the hypothesis that you have given us. Universal College, they're saying soil sample A is best water A. Soil sample A has the best water holding and is the best for rice growing since it has closely packed small particles. That is wonderful. So universal, they are saying that soil sample A is the best water holding soil and is the best for rice growing because it has closely packed soil particles. Yeah, I'm seeing their prediction. I'm seeing there's something interesting. So for them, they are saying, when they look through, they are saying it is a soil sample A, which has the best water holding capacity, hence good for growing rice. And they are having a reason that they have seen when they look at soil sample A, and then they look at soil sample B, they have seen that soil sample A has closely packed particles, hence to retain more water. Yes, that is very wonderful. Another school, Bishop's Girls, Rushere. The soil sample with the highest water retention is the best for growing rice. Hey, Rochelle, for you, which one is that? Which one is that? Yes, it is true. The best sample. It is true the sample with the highest water retention is the best for growing rice. But now you just pick any soil worldly, any sample A and B, and you say it is that one, and then you give us a reason. Then Opio Quinto is saying if either soil sample A or B has the highest rotation, then it is the best for growing rice. No, Opio, you have to focus. You can't have two predictions. You can't have two predictions. It must be one. Then Komakech Rogers is saying soil sample A is the best soil sample for growing. Okay. Hill City, they are saying soil sample A is the best for growing rice because it has high water retention than soil sample B. How have you known that it has high water retention than soil sample B? Now, the because should it be now based on the reasons that you have, maybe the features that you have seen? Why do you think it is A that has highest water retention capacity? Why do you think it is A? That's the reason that we need. Okay, that is all from the chat. Let me listen to some hands. Those ones who have not been given chance to. Okay, Bishop's Girls. Bishop's Girls Rushere.
Soil sample A. No. Soil sample B is the best for growing rice because it has closely packed particles.
You have not connected it to the aim. You have not connected it to the aim. Who is this? The school that is using the administrator account. The school that is using the administrator account, please give us a hypothesis and you tell us the name of the school as well. The school using administrator account. What is the name of the school and what is your hypothesis? We can't hear anything. Okay, lastly, Royal College Namugongo. Royal College Namugongo, what is the hypothesis? Royal College Namugongo.
Soil sample A is the best for growing rice because it has a high water retention and low drainage capacity.
Because it has a high water retention. Now, why not soil sample B? How have you known? In other words, how have you known that soil sample A has high water retention? How have you known that? That would be now the reason that we're looking for. Royal College.
Small which are clumped together.
Pardon?
So they have small particles which are clumped together. So
it has small soil particles. Now that becomes the reason. That becomes the reason. That becomes the reason. Okay. Please, someone using the KLC account. KLC account. Stop whatever you're doing. Okay. Okay. So now let us go with those ones. Now we are saying that in this case, you have two soil samples, A and B. Then you ask yourself, what do I want to do with these soil samples? The aim is saying you want to compare retention capacity of the two soil samples, A and B. Now, what is your prediction? Even before you carry out this experiment, what do you expect to get? The prediction of the outcomes, the expected outcomes. You will say that maybe according to what I'm seeing, it is a soil sample A, which will have the highest water retention capacity. Which will have the highest water retention capacity. Then, which reason are you basing on to tell us that it is a soil sample A, which has the highest water holding capacity? Then now it's when you can say, because it is having small soil particles with the small air spaces. Because we know that soils with small air particles will have small air spaces, hence water will not be able to go through. That one is known. That is what we expect. So that becomes the hypothesis. In other words, if it were me, I would say that it is the soil sample A. Of course, now don't ask again, why not soil sample B? I'm just picking the soil samples randomly. So I would say that soil sample A has high water retention capacity because it has small soil particles, hence can easily be water logged. Hence can easily be water logged. Now, that would be my hypothesis. Or now, the hence I may not add it there. The hence I may not add it there. But what is very critical here is the acknowledgement that soil sample A will have high water retention because it has small size particles with small air spaces. Now, that becomes my hypothesis that it means I'm carrying out this experiment of comparing water retention with, but bearing in mind or knowing sure that soil sample A should be the one to have high water retention capacity because of the reasons that they have given or because of the reason that they have given. Because it has small soil particles, small air spaces. So that now, how do I rate my hypothesis? How do I rate it? Or how do I state it? I'll basically say soil sample A has high water retention capacity because it has small soil particles with small air spaces, full stop. That is my hypothesis. That is my prediction. That is my prediction. So that is how we state hypothesis. That's how we state hypothesis. Now, so I hope we now know how hypotheses are stated. Now I'm seeing some hands up. Is it that they want, there is some clarity they need? Or, okay, so if you don't have any question to ask, no, if you have a question to ask, just questions, you can keep your hand up. But if you don't have a question, then you first lower your hand, then we give those ones with questions a chance to ask. Okay, let us go to someone using Taiba International School. You are most welcome. So Taiba, anyone there to give, is it a question?
According to the question that we have here, they are not showing us whether which soil particle has which characteristics. Maybe let them say sample A has tiny particles. So in the next thing, are they going to give us the characteristics and base them of the soil particles or no?
Okay, that is a very interesting question, and thank you for that. Now, we can, in this question, the way how we are doing it now, we are not sure what is soil A and what is soil B. We don't know. We are not sure. We don't know. But that's why I'm saying that for us, let us just pick any soil sample randomly. So we just picked randomly. Now, when I say that soil sample A has high water retention because it has small soil particles. So I'm assuming that the two soil samples that I'm having, I can clearly see with my hand, with my eyes, that this soil has small soil particles, this one has large soil particles. Or I can even clearly see with my eyes that this soil sample has small air spaces, this soil sample has large air spaces. So you don't have to mind, or you don't have to worry about which one is which. We are assuming that you have the two soil samples, you're able to see them with your hands, with your eyes, then you tell us. Because if you're given clay and sand and you're looking at them, which one do you expect to have high drainage? Now, drainage. Obviously, you expect sand to have high drainage. But why do you think sand has high drainage? Because when you look at the sand itself, you'll see that it is having large air spaces. You see that the particles are big with large air spaces. Meaning that when you pour there the water, all the water will just go through. So that's how we are able to know that which soil sample maybe has which properties. So that one can be based on what you're seeing. Okay, then a last question from Smakon International School. Smakon International, are you there? Okay, okay. Now, the chance is gone. Let us now proceed. Let us now proceed to another thing. Now, I'm taking a lot of time on aim, hypothesis, and also variables, because these are the key things. If you have these ones wrong, then you may not be able to proceed with the rest of the work. Okay. Then, after the hypothesis, we now go to the variables. Now, what are variables here? Variables, what are variables? Variables. Now, variables, these are basically things or factors that when manipulated or changed, the word manipulation means to change, that when manipulated or changed would have an effect on the results. That's what we mean by variables. Things that when manipulated or changed will have an effect on the results. That's what we call the variables. And we have basically three types of variables: controlled for variables, independent variables, and dependent variables. Now we're going to see what are controlled for variables, what are independent variables, and what are dependent variables. I will start with this very scenario here. When you look at this scenario, what are the variables here? What are the variables? Bearing in mind that we are saying that of the things that you want to use, or what you want to do, there are certain things that you know. If you change them, or no, actually, let me say varying. Actually, let me use the word varying is like change. If you vary them, or if you change them, they will have an effect on your results. This is what we're calling variables. That if you vary them, or if you change them, they'll have an effect on your results. And you can choose to change them intentionally, or you don't want to change them, because you know, should you change them, they'll have an effect on your results, and you don't want to see that. Or you'll have to change them deliberately so that you can monitor which effect are they having on your results. These are the variables. Now, when you look at this item here, what are the variables? In other words, what are those things that if you change them or if you vary them, they will have an effect on your results? What are they? Okay. I'm seeing some hands here. Okay, I'll go with the first one. Madu SS. Madu SS.
I have not understood the hypothesis. You told us that it is a prediction. What if my hypothesis be like this? Both soil samples A and B are suitable for growing rice, because we are just predicting, we are aiming to get the reasons.
Let me now engage you briefly. Now, remember, you're saying you are predicting to get the reasons. Which reasons? The aim. The aim was to compare water retention. That was the aim. Now, basing on the aim, what is your prediction? Because you're comparing water retention of soil samples A and B. That was the aim that we said you work with an experiment to compare water retention of soil samples A and B. Now, what is your prediction? Over to you, Madu SS.
Okay.
Is it coming out clearly?
My prediction is the soil with a high retention having a soil sample B having small particles. The soil sample B have small particles and air spaces. It's suitable for rice growing.
Still, you have not linked it to the aim. Because you're saying soil sample A has small soil particles, is suitable for growing rice. What was your aim? Remember, the aim was comparing water retention of soil samples A and B. Are you trying now to get the concepts?
Somehow. But for me, I'm not getting you.
Where are you lost from exactly?
But if we are just predicting, if let me say that I just want to know whether I just want to find out which of the two soil samples has a greater water retention capacity.
Exactly.
Now, and for you in a reason, when you've been giving a reason in the hypothesis, you've also specified that a certain soil sample has a higher retention capacity, yet it's the one you are finding.
No, remember, I have two soil samples. And I'm saying that I want to compare which of the two has the highest water retention capacity.
Yes.
But by looking at those two soil samples, are you not able to predict which one would be having a high water retention? Are you able to do it or not? Just by looking at soil samples.
I thought that in practicals, we just find out, not just to see with our naked eyes.
Exactly. Now, that is a very good submission. Now, in life, you don't go to do something without expectations. Never do that. Don't just just say, I'm going to do something, I will find out what I find out. You must be having some expectations. Then afterwards, you evaluate. This is what I thought I would get. Have I got it or not? If I have got it, then you know all is well. If you don't get it, then you go back and investigate how you reached there. I'll give you an example. If I want to carry out a procedure to test for presence of starch, Now, if I give you starch solution and I give you iodine, I ask you, find out whether that solution will be having starch or not. What comes into your mind? You have a solution and you have iodine solution. Now, what comes into your mind is this. You'll know that if I add this iodine to the solution, I will either get a brown solution or I will get a black solution. Now, that is a prediction. You are predicting that if I add iodine to this solution, I'm either going to get a blue-black solution or a brown solution. That is now your prediction. Then you go ahead and you add the iodine to the solution. With expectations, you expect to get either brown or blue-black. Then indeed, when you add it there, you are either going to get brown or blue-black as you had predicted. Suppose you just mix and you get green. What comes into your mind? You'll have to repeat the experiment. You'll have to repeat the experiment. Why? Because you know when you add iodine to solutions, you can never get green. So it means you had expectations even before carrying out the experiment. And that is why you're able to make a conclusion. If you get green, you'll say that, no, something is wrong. I have to repeat the experiment. So then also when you're doing these scenarios here in practical number 1, you must have expected outcomes, that this is what I expect to get. Then you go on and you carry out the experiment. Then you evaluate what you have got according to what you had expected. But you never say that, I cannot predict. Let me just do and see what I will get. If you do it, it means that you don't know what you're going, and even you're going actually to get lost. Because whatever results you get, you didn't know what to expect. You get it? So that's the importance of predicting or the hypothesis. Yes, you're going to find out, but you also have expectations basing on what you are seeing, or maybe basing on what you already know.
Now, my last question is, now if you give a reason that maybe soil sample A is the one that is better for growing rice with a reason, and remember, that hypothesis is just to be proven. And what if it comes that by the end of your experiment, then your results are now against your hypothesis?
That is very interesting. Now, when you get your results, be sure that they will either be in line with your hypothesis or they will be against your hypothesis. Either way, it is correct. Now we shall wait to see how do you explain that. Now that one comes, that's why you see on our report, we have conclusion. You must conclude. And later we shall see under conclusion, you now compare the results and your hypothesis. Then now you tell us. If say maybe the results came out contradicting your hypothesis, then what could possibly have gone wrong, or why are they coming out like that? Now we see how you are able to conclude. It doesn't mean that your hypothesis was wrong. The hypothesis was very correct. Only that now the results have come out when they are not in agreement with the hypothesis. But now you shouldn't doubt your hypothesis, because you giving that hypothesis, you are basing on solid evidence, solid proof. Like for instance, if you know you have clay soil and you have sand soil, when you look at sand, you can see large soil particles and large air spaces. But when you carry out your experiment, you find out that, things are the opposite. Then it means something is wrong with the clay. Something is wrong with the clay. Then it's now what you have to castigate in your conclusion.
Okay, now. Thank you, sir.
Okay, you are welcome. Then let us now proceed to the variables. The questions will now come later. Let us now variables. Now I need a response, an answer. If you're only commenting or if you're only giving us the variables, you're only giving us the variables. And remember we said that variables, these are the things that if when manipulated or changed, they can have an effect on your results. Therefore, you either choose not to vary them, or you choose to deliberately vary them that you can see the effect they are having. Okay, so I will start with the Skyland leader. Skyland leader, you can unmute.
Okay. Our control variable, I think it is soil.
Huh? How about the soil? What exactly about the soil?
The soil, the volume of soil is should be constant.
Volume of soil is going to be constant. That is wonderful. That is one variable. That if you want to measure, because you have two soil samples, A and B, therefore, you must measure the same volume of soil sample A and the same volume of soil sample B. If you vary the volumes, then you're sure you are not going to get reliable results. So that is interesting. Thank you. So that is one variable. Which other variable are you seeing in this scenario here? Which other variable? I will now select Nawandala SSC Ganga. Nawandala, are you there?
Master, the dependent variable is the volume of the water added.
Now, volume of water. Now, why are you saying it is dependent?
It depends on the amount or the volume of the soil sample measured.
Sure. Volume of water added. Not really. Not really. Now, when you are giving these variables, please don't commit yourself to saying whether they are controlled for or dependent or independent. Why am I saying don't commit yourself? Now, the example he has given us, actually, volume of water added is a variable, but it is not a dependent variable. It is not. Why? Because we have to keep it constant. The same volume of water you're going to pour in soil sample A is the same volume of water you're going to pour in soil sample B. You are not to vary the volumes of water added. You keep them constant. So constant variables are not dependent variables, are not independent variables. So please, if you're not sure of the dependent and the independent, don't commit yourself. Don't commit yourself. So the second variable that we have here is volume of water added. And we are saying all these variables, volume of soil added and volume of water added, they should be kept constant. You are not to change them. You are not to vary them. Now, variables that should be kept constant, we call them controlled for variables. Variables that should be kept constant are called controlled for variables. That's what we call them, controlled for variables. Okay, then now for the interest of time, we may not hear from, because we expect to close this session by 6. Now, this scenario here doesn't have dependent variables. It doesn't have independent variables. Why? Suppose I design my experiment in this way. I'm going to assume that I'm going to rely on how much water is going to be collected. How much water is going to be collected. I'll have my soil sample A. I pour it in a filter funnel. Maybe I have poured there 5 mils of the 5 centimeters of the soil sample A. I also measure 5 centimeters of soil sample B. I put in another filter funnel. Then I pour the same volume of water in either of the soil of the filter funnels. I wait for maybe 2 minutes. Then after 2 minutes, I see how much water would I have collected from soil sample A and from soil sample B. If in soil sample A, say for instance, I have collected 3 mils out of 5 mils added. So soil sample A, I'm assuming I've collected 3 mils out of the 5 mils added. Then soil sample B, I'll have collected 4 mils out of the 5 mils added. But after 2 minutes, so I must also keep the time constant for either of the experiments. So now in this case, time also becomes a controlled for variable because I'm keeping it constant. I'm not going to vary time. I'm not going to say that when I pour in soil sample A, I'll wait for 10 minutes. Then when I pour in soil sample B, I'll wait for 5 minutes. Trouble going to come. You're not going to get reliable results. So because you're also keeping the time the same, time also becomes a controlled for variable in this experiment. So hence that is our third variable in this scenario here. Now, back to what we have collected. So it means that if you have collected 3 mils of A from A and 4 mils from B, that is all. So I don't have any other variables there. I don't have dependent variables. I'm not having independent variables. Actually, I'm going to give you another scenario where we can have dependent variables and independent variables. So in biology, there are 4. I know in chemistry, they must have told you that we have all scenarios have the 3 types of variables: controlled for, the dependent variables, and the independent variables. Chemistry, the same thing. Now, in biology, it is not the case always. It is not the case always. We can have some scenarios where we only have controlled for variables. We can have some scenarios where we have all the 3 types of variables. So don't take it that it is the same as for other subjects. Okay, I'm just quickly perusing through I'm just quickly perusing through the inbox. Okay, now people are saying, can I write my hypothesis in a negative form? Now, writing the hypothesis, whether you write it in negative form, whether you write it in positive form, as long as we can see you are predicting, that is all we want. Whether you write it in negative or positive, as long as you are predicting, that is all we want. So any form you can write your hypothesis. Someone is saying that the hypothesis should be written in future tense, because now we are not saying that write it in future tense or past or what. As long as you are predicting, whether you can predict in future tense or past tense or which type of tense, there are no limitations. As long as you are, they are not going to score your hypothesis basing on the tense that you have used. They are going to score your hypothesis basing on the prediction that you have done. And if possible, if you have put there the reason. Okay. The question is that what if the experiment proves the hypothesis is wrong? Should the hypothesis be stated before or after? Please, you first state the hypothesis. You first state the hypothesis. Actually, we shall see another sample. There's a scenario which I have, and you see the dangers of stating, of first doing the experiment, then you come back to hypothesize. Okay, Davis Murundi is saying that I thought giving a reason for predicted outcome in the hypothesis may not be relevant. I thought this discussed an explanation on the results. Well, now, giving a reason for the predicted outcome, is it relevant or it is not relevant? Now, look at what I did here. Now, when you look at what on this slide, I said hypothesis is the prediction of the outcomes in a bracket with reason. Now, the reason itself is not going to be scored. It is only the prediction that we are looking out for. But I'm saying you should predict with the reason at the back of your mind. You should predict with a reason. You should predict with a reason. Whether you write it or you don't write it, it's up to you. But your prediction should be based on a reason. For instance, don't just say that soil sample, now I'm going back, soil sample A has high water retention capacity. And we say, and when you look at the soil samples, you find that actually soil sample A is sand and soil sample B is clay. Then we ask now, why are you saying that sand has high water retention? Then a learner will say, because I'm predicting, it is just a prediction. I'm just guessing. No, please, you must predict with the reason at the back of your mind. You can either write that reason or you may not write that reason. Actually, what is important is the prediction. What is important is the prediction. Okay. So I think I have responded to that question there. Someone is saying, request someone to help me send the scenario we are using. Hey, we send it where? I think you're seeing it on the screen. So just write it down because you're seeing it on the screen. It is already on the screen. Okay. I think that time taken against amount of water collected, the independent variable in soil sample A and B, please, we don't have any independent and dependent. We shall let us see what we mean by dependent and independent variables. Okay. Can I, please, 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 if you're not sure of what dependent variables are and what independent variables are, don't commit yourself to say that soil, maybe volume of soil is independent. For you, just write on the variables, you just write there, volume of soil, full stop. Volume of water, full stop. Time, full stop. That becomes your variables. Don't commit to say whether dependent or independent if you are not sure. Okay. In case a question does not have a part with an independent variable, can we come up with it? Please follow the task. Follow the task. Don't force. If the scenario is not having an independent variable, that is that. Don't force it there. You may force it there and you end up swelling everything. Okay. Then, now, what are independent variables and what are dependent variables? That's why we're now going to what are dependent variables and what are independent variables. I will use an example of catalase. I'll use an example of catalase. I don't know if the teachers have taken you through catalase experiments. I don't know if they have done that. But however, I'm going to take you through that catalase to know which are dependent variables and which ones are independent variables and also controlled for variables. Now, I'm going to demonstrate for you an experiment, but in this experiment, I'm going to use catalase enzyme and hydrogen peroxide. Now, what is catalase enzyme? Catalase enzyme is an enzyme that is found in tissues. It is found in tissues. It can be found in either the liver or even in Irish potatoes. So I have an Irish potato with me here. Can be found either in the liver or in Irish potatoes, like this one that I have here. Then, now, the catalase enzyme normally breaks down hydrogen peroxide into water and oxygen. That is what catalase enzyme does. That if you get a tissue of Irish potato, or if you get a piece of liver, this liver or Irish potato is containing the enzyme, catalase enzyme. Then should you drop it in a solution of hydrogen peroxide, the catalase enzyme in the tissue will break down hydrogen peroxide. And once it breaks down hydrogen peroxide, we shall see bubbles or froth forming at the top of the solution. That is how catalase enzyme behaves. Now, I'm going to demonstrate an experiment using this catalase enzyme. Now, what does it do? Now, you can see from these pictures here. If you have catalase, if you have a piece of liver, for instance, and you drop this liver in a solution containing hydrogen peroxide, there will be bubbling. In other words, now this bubbling can represent the reaction rate. If we see we have rapid bubbling, if we see we have a lot of bubbles forming, then it means the reaction was very fast. If we see we have very little froth forming, like when you look at the test tubes here, the first one we have very little froth forming. So it means in the first one, the rate of reaction was very slow, or the bubbling is slow. Then in the last one, the bubbling is very high. Now that one, we can use that one to know or to estimate how fast or how quick the rate of reaction was. Now, I can have maybe an experiment with an aim of investigating the ideal pH for, say, catalase enzyme. So my experiment, I want to investigate the ideal pH for catalase enzyme. Now you remember we said enzyme activities. Enzyme activities can be one of the areas where number ones can come from. Now the next one from seeing is for soil. Now what of enzyme activities? Now we know that enzymes work best under specific pH. Enzymes work best under specific pH. Now, if they work best under specific pH, now we can design an experiment to find out under which pH does catalase enzyme work best. Under which pH does catalase enzyme work best? So I'm going to do some demonstration, then we see. So this is the aim. I want to investigate the ideal pH for catalase enzyme. Now, how do I design my experiment? I have first think of which materials do I need to execute this aim here. How exactly can I investigate the ideal pH for catalase enzyme? How can I do it? Okay, so I'm going to assume I'll design my experiment in this way. Let me highlight my video so that the illustrations can come out clearly. Okay. So I hope my video has filled your screen. I hope my video has filled up your screen. So the aim of my experiment is this. I want to investigate the ideal pH. I want to investigate the ideal pH for which catalase enzyme can work. So how am I going to design my experiment? I will know that for me to execute this experiment, I must be having my Irish potato, or another person can use the liver. So me, I'm going to use the Irish potato. So this is the material that I'm going to use. I have my Irish potato. Now the Irish potato is going to give me the catalase enzyme, this one here. Then I will need test tubes. I have my test tubes here. Then I will need hydrogen peroxide. I have my hydrogen peroxide here. It is just a catalase solution. We even think it is water. It is very deadly. We have catalase, so the hydrogen peroxide. Then what else will I need? I will need measuring cylinder, need the measuring cylinder. Then what else do I need? I will need solutions of different pH, because I want to see under which pH does catalase enzyme work best. So I must be having solutions which are going to help me generate different pH. And I know we have 3 pH. We have acidic pH, alkaline pH, and neutral pH. So for acidic pH, I will use hydrochloric acid. So I have my hydrochloric acid here. Then for alkaline pH, sodium hydroxide. So I have my sodium hydroxide here. So I know I'm set. I have whatever I need. Now, what am I going to do? What I'm going to do, I will say, I will need, first of all, test tubes. That's what I say, 3 test tubes are enough. So 3 test tubes are enough. So I have my test tubes there. I have my test tubes there. So what will I will know that in one test tube, I have to put hydrogen, sorry, I have to put hydrogen peroxide in all. So in all, I'm going to put hydrogen peroxide. Now, if I may ask, do I have to vary the volume of peroxide added in each test tube, or the volume of the peroxide must remain the same? What do I need to do there? Someone can tell us. Do I have to change the volume of hydrogen peroxide, or I don't have to vary it? So on Nono Memorial, what should I do?
You should not vary. They should be of the same unit.
Therefore, which type of variable is it?
Control. A control variable.
Exactly. So from this aim, I already have one variable, controlled for variable, that the volume of hydrogen peroxide should be constant. Now, that is the variable. That's how now we start knowing the variables. So I will measure, so it means I'm aware that volume of peroxide is a controlled for variable. So I will say I'm going to use 2 mils of the peroxide in all the test tubes. So I will measure by 2 mils. So this is the first 2 I put in my first test tube. So I have measured my hydrogen peroxide in every test tube. Then, secondly, I now have to change now the pH. I have now to look at the pH. In one test tube, I must make the pH acidic. In another test tube, I must make the pH alkaline. Then in another test tube, my pH should be neutral. Why? Because I want to find out under which pH will my catalase enzyme work best. Under which pH will my catalase enzyme work best. So I will have acidic pH. Now, how do I make this one acidic? Make this one acidic, it is simple. I'll get another measuring cylinder. I'll add there hydrochloric acid. If you add an acid in anything, it means you'd have changed the pH of that solution. So I would just add very little acid, not much. So it means this solution here is acidic because I have added there hydrochloric acid. Then I'll get another measuring cylinder. Now in test tube 2, this one here, I want to add to make this alkaline. I want to make this pH alkaline. So I'll add there sodium hydroxide. Now sodium hydroxide will make things alkaline. So also measure about 2 or 1 ml of sodium hydroxide. So my solution here is the alkaline because I have added there sodium hydroxide, like that. Now, in this one here, I will not add there anything because I want my pH to be neutral. Therefore, in test tube 1, this is acidic. The pH is acidic. In the test tube 2, the pH is alkaline. How is it alkaline? I added there sodium hydroxide. In this one here, the pH is neutral because I've not added there anything, like that. Now, if I may ask, in these 3 test tubes, what have I varied? What have I varied in these 3 test tubes? What have I varied? Let me see here. Opio Quinto. Opio Quinto, you can unmute. Opio Quinto is not there. Bishop Girls, Rushere, you can unmute.
The volumes,
okay.
The volumes of the solutions put in the 3 tests.
Which volumes did I put? And volumes of what? Okay, let me another one. St. Mary's Assumpta Girls. St. Mary's Assumpta Girls.
Okay, sir, you varied the pH of the solutions.
That is wonderful. I have varied the pH. Here, pH is acidic. Here, it is alkaline. Here, it is neutral. So in all these little tubes, I have varied the pH. Now, what I have varied intentionally becomes my independent variable. What I have varied intentionally becomes my independent variable. Altogether, therefore, we are learning of a second variable in this scenario here, that we have now an independent variable called the pH. Therefore, in this case, pH becomes my independent variable. So in this scenario here, we are now seeing we have a controlled for variable. We have said it is the volume of hydrogen peroxide used. Then we have now an independent variable, that is the pH. Why? Because I am varying the pH intentionally so that I can see the effect that variation will have on my rate of reaction. I hope that one is somehow clear. Okay. Then the next step is, now I have my solutions ready. Now what next? I have now to bring now my catalase enzyme. Now I'm going to add catalase enzyme in these test tubes. Then I see whether the reaction takes place or the reaction does not take place. Now, remember we said that catalase enzyme is found in the tissues. So for my case here, I'm going to extract out my catalase enzyme in the Irish potato. So what exactly am I going to do? I'm going to just cut pieces my of this Irish potato. I'm going to cut pieces. So I'm going to add pieces of this Irish potato in my test tube, because these pieces are the ones which are providing the catalase enzyme. So I have 3 test tubes. Therefore, I must cut 3 pieces of the Irish potato. Now, if I may ask, should I have to vary the pieces of the Irish potato, or I should use equal sizes of the Irish potato pieces? What do I have to do? Koja SS, what do I have to do? Smakon International, what do I have to do? People are preferring to respond inbox. Solid Rock, Arua, Solid Rock, what do I have to do?
Yes. Are you getting me?
Yes, very clear.
You use equal pieces of the Irish potatoes.
Now, is that a variable or not a variable?
It's not. It's a variable.
Well, which type of variable is it?
It's a variable, sir, because you
Which
control the pieces of the controlled variable.
Exactly, it is a controlled for variable. That is wonderful. So it means that in my test tubes, I'll have to add 3. Sorry, I have to add 1 piece of the Irish potato, and the Irish potato should be of the same size. In other words, I'm trying now to control the sizes of the. So it means that now in this scenario, we are now learning that we have 2 controlled for variables. That is the volume of hydrogen peroxide used and the size of the Irish potatoes. Then now, if I may ask, what now is the dependent variable there? Now, the dependent variable is that variable that is, in other words, when you look at the independent variable, what effect does it bring? Or in other words, what does the independent variable actually affect? What does the independent variable affect? Now, in this scenario here, the independent variable will affect my rate of bubbling. I'm just now trying to reduce the time. My independent variable will affect the rate of bubbling or the rate of reaction. Therefore, the rate of reaction becomes my dependent variable. My rate of reaction becomes the dependent variable. So it means that now in this experiment here, we have learned that we have all the 3 types of variables. We have controlled for variables, we've said, the size of the Irish potatoes and the volume of hydrogen peroxide used. Then we have the independent variable, that is the pH, and then the dependent variable, that is the rate of reaction or the rate of bubbling. Now let us see. When I add these Irish potatoes in I don't know whether we shall be able to see, or we need something like a darker background. Let me see where we shall have. Okay, now I'm going to add so let me try to see. I want to make sure that whatever we are seeing is very clear. It works like that. Let me see. I think there it can work. I think that now you're able to see the volumes. So I will add my Irish potatoes, my cubes. Now I think you're seeing the reactions there. Now when you look at them, I think you're seeing the bubbles formed. Now, which test tube are you seeing more bubbles? Which test tube are you seeing more bubbles? You just type inbox. Which test tube are you seeing more bubbles? Which test tube are you seeing more bubbles? Test tube 2, the middle one. That is wonderful. That is wonderful. It is the middle test tube. You actually see. They are about even to pour. They are about to pour. You see. Are you seeing? This test tube, the rate of bubbling is very slow. In this one, very rapid. Then in this one here on the side where my finger is, it is moderate. It is moderate. So what does it mean? It means that the middle, in the middle test tube, rate of reaction is rapid. The rate of reaction is very fast. And now let me see if you had tracked. Was the pH alkaline or neutral in the middle test tube? Was it alkaline or neutral? Still, you can put in the chat where you can easily read. Was it alkaline, neutral, or acidic? Oh, people were recording. That is wonderful. The middle one, we added there sodium hydroxide, and it was alkaline. So what does it mean? It means that, remember, we shall now go back to the aim of our experiment. Our aim of the experiment. We said the aim was to investigate the pH that favors the rate of reaction of catalase enzyme. Now, haven't we found out that catalase enzyme works best? Actually, you can even see the things are almost pouring. The things are almost pouring. Are you seeing? Are you seeing that test tube? Actually, they are now pouring. So it means catalase enzyme works best in alkaline pH. And how have we found out? By carrying out an experiment. So it means that it is very possible to investigate these experiments here if you have your aim right. Remember, my aim was to investigate the favorable pH for the action of catalase enzyme. And I designed my experiment very well. After designing it, now here I have gotten the outcomes altogether. So these are the outcomes. So now this experiment, I basically wanted to use it for us to be able to find out or to know which one, to be able to know where we have the difference between controlled for variables, independent variables, and dependent variables. And in that, we have used an experiment about this catalase enzyme, and we have seen it works. It works, and it is very easy to design this experiment. It's very easy as long as you know what you're doing, and as long as also your aim is very clear. So you can see our aim was to investigate the ideal pH. And from the things we have all seen, that the ideal pH for catalase enzyme is alkaline. Altogether? Now, now let us go back to our report. So I'm now assuming that we know the variables now. We can tell what variables are. Then after the variables, the next thing on our report are the materials. Now, for the materials, you just basically list the things that you're going to use. Now you saw how I carried out my experiment. I said that what did I need? I first got everything that I needed. I said I needed test tubes. I got them. I needed a measuring cylinder. I got it. I needed an Irish potato. I got it. I needed hydrochloric acid. I needed sodium hydroxide. I needed hydrogen peroxide. All those. Then I put them before me. Then I carried out my experiment. So in the materials here, you outline all the things that you are going to use, all the things that you need to use. That is the materials. And how do they score these materials? These materials, they will give you a maximum, they will give them a maximum of 3 scores. Three scores. If you list all the materials that are needed, you'll get all your 3 scores. But if you list all the materials and you put there a material or an apparatus that you are not going to use, you lose scores. You lose. They will punish you for that. If suppose you have written everything and then you also write a material that you're not going to use, instead of getting 3, you get 2. If you write more than 1 materials that you're not going to use, instead of getting 3, you end up getting 1. So therefore, when you're listing the materials, only list those ones that you're going to use. Okay. Then the procedures are now procedures here, a bit technical, but very easy. What are procedures? You also how I designed my experiment, how I designed it. What I say, I got my test tubes. And after getting my test tubes, I measured 2 cubic centimeter of hydrogen peroxide, and I poured that in each of the test tubes. What else did I do? I measured 1 cubic centimeter of hydrochloric acid. I put in test tube 1. Then I measured 1 cubic centimeter of sodium hydroxide. I put in test tube 2. Then I cut 3 equal pieces of the Irish potato, and I dropped them in all the 3 test tubes. Then after that, I observed the rate of bubbling. Now, what am I narrating? I'm narrating the procedures. Now, can't you translate that one into writing? Whatever you do, you write. Cut 3 equal pieces of the Irish potato. Measure 1 cubic centimeter of sodium hydroxide. Pour in test tube 2. Measure 1 cubic centimeter of hydrochloric acid. Pour in test tube 1. Now, those are the procedures. That's how you just outline them. That's how you just outline the procedures. In other words, procedures, these are the steps that you go through, all the steps that you will go through to get your results, That's what they mean by procedures. I hope that one is clear. The questions I always get from learners, which tense should I use when recording my procedures? I will mention this. Use any tense that you are comfortable with. Biology, we are not for tense. Tense is for English. We are not teachers of English. For us, what are we looking for? Did you follow the procedures? If I can follow these procedures, can I get the results? Just that. So please don't stress yourself with which tense to use. Write the steps. Whether you write them in present tense, whether you write them in future tense, whether you write them in past tense, as long as they are procedures and they are clear. I hope that one is rectified. And of course, someone was also asking which tense should the report be written. It is not about the retense. Any tense that you write, it's up to you. Okay. Now, how will they score your procedures? Now, procedures procedures. Now, procedures, the maximum score they will give them. I'm finding a very interesting question here from Denise. Denise is commenting on our experiment that we have just demonstrated here, that theoretically, is it true? Let me point on that one. That theoretically, is it true? Because from our findings, you see the middle test tube, from our findings, we have found out that catalase enzyme works best in alkaline pH. Why? Because we have seen the rapid or the highest rate of bubbling. Now, theoretically, is it true? Now, it is not about whether it is true or not true. It is about what have you got? What have you got? So for you, you record what you have got. And since we have done it practically, and we have gotten the results, then it means, even theoretically, it is true. But don't claim whether it is true, whether hydrogen peroxide works in acidic or neutral. Just carry out the experiment and find out where it is at where the reaction is, or where the reaction occurs at a high rate. Okay. Well, should I use pronoun I in rating procedures? Please, it doesn't matter. It doesn't matter whether you use the pronoun, whether you don't use whether you say I did this, I did this, as long as the results are, as long as the procedures are clear. Then Chisana says they're asking how many procedures are expected. How many procedures are expected? No, we don't actually. When we're scoring the procedures, they're not going to count how many procedures. For us, we want to see what are the steps that you have taken. It is not about how many steps. It is what are the steps that you have taken. And this is how we score the procedures. Let me display to you this one here. See it. Okay. Okay, like this. Now, procedures, we said the total is 6. But this 6 is gotten in 2 twos. 2, 2, 2. Now, when a teacher is scoring your procedures, they will first ask themselves the question, are these procedures relevant? Are they relevant? I'll read through all your procedures. Then I ask myself, are these procedures actually relevant? Are they fine? If I find out that the procedures are very okay, then I'll give you 2. I'll give you 2. If the procedures are very okay, I'll give you 2. Then, if I will also ask a question. Yes, the procedures are relevant, but are they correct? Are they accurate? Are these procedures accurate? By accurate, I mean, if you're saying when you're carrying out maybe for example, procedures for food tests, we know that, for example, if you're carrying out the proteins test, what do you do? For proteins test, you add this food solution in a test tube, then you add there sodium hydroxide. Then after sodium hydroxide, you add there copper 2 sulfate. That is the correct procedure for proteins. Suppose you rate that you added copper 2 sulfate followed by sodium hydroxide. Mind you, if you do it like that, if the proteins are present, you'll still get a purple color. Proteins are present. But the question we shall ask ourselves, yes, that procedure is relevant. You'll get your 2. But is it coherent? Is it correct? Is it the way they carry it out? If no, we shall not give you the second set of 2, the second 2. We shall not give you the second 2. Then the third 2 to make the 6, managing controlled variables. What do we mean by managing controlled variables? When we were doing our procedures, we said measure 2 meals of hydrogen peroxide into each test tube. Now, what have I done there? I'm now showing how I managed the volumes of hydrogen peroxide. It means I'm now demonstrating how I controlled my variable of hydrogen peroxide. Then again, in the procedure, as I said, cut 3 equal pieces of Irish potato. Now, what is that? I'm showing how I managed or I controlled the sizes of the Irish potatoes. Now, if I sense that in your procedures, then you also score this 2 of managing controlled variables. Then together in the total, you get 6 on the procedures. Now, I've not said that I count that if you have 1 procedure, you get 1. If you have 3 procedures, you get 3. No. Procedures, irrespective of how many steps you have written, I will just read through all of them and finish them. Then I start asking myself questions. Are these procedures relevant? Are they coherent? Have the variables been managed? Then if all is done, you get your total 6 scores. So that is how the procedures are scored. The questions will come later. The questions will come later. Someone is saying, can procedures be tabulated? Don't tabulate the procedures. You write it. Just outline them. Why do you want to tabulate things? Just outline the procedures. Outline them. Outline them. Okay. Someone is asking that, what was your hypothesis? Yes. What was my hypothesis, by the way? What was my hypothesis? Now, in this case, to me, my hypothesis was in my experiment here, my hypothesis was because I'm investigating the ideal pH for catalase enzyme. So one thing I'm sure of is that catalase enzyme will work under specific pH. That is that. Catalase enzyme works under specific pH. What is that pH? I don't know it. Therefore, I will carry out my experiment and at the end of the day, find out which specific pH actually does catalase enzyme operate or work. So to me here, my hypothesis was catalase enzyme works under specific pH. Full stop. That was my hypothesis. That was my prediction. That I expect to find catalase enzyme working best under a specific pH. Then later, after doing my results, then I will now be able to tell which pH exactly. Now in my conclusion, I will now come and say, indeed, catalase enzyme works best under alkaline pH. That's how I would have concluded. But my hypothesis was simply that catalase enzyme works best under specific pH. So that was my hypothesis. That was my hypothesis. Okay. Someone is saying, what of the case of food tests? Can the procedures still be tabulated? Now, if you're saying that, what of the case of food tests? Can procedures be tabulated? Then I'll also ask you a question. For the food tests, can't you write them without tabulating? That is the question. Can't you write the procedures for food tests without tabulating them? If you can write them, if you can write without tabulating them, then that is the right thing to do. That's the right thing to do. But for you still, if you still insist that you have to tabulate them, it's up to you. It's up to you. They will not penalize you for tabulating the procedures, but it is risky. It is risky. And don't risk. You may end up mixing up things. You may end up mixing up things. But procedures can be written in any form, whether tabulated or not tabulated. procedures can still be written in any form, Okay. Okay. Then, I think now we can proceed. I think I've answered some of the key issues. Now, what next after our procedures? What next after our procedures? Okay, Royal College, they are saying, what if the hypothesis is not coherent? Would the whole report be irrelevant? No. If the hypothesis, actually, if now, the hypothesis, if you fail the hypothesis, or if you don't read the hypothesis, we still go on and read other things and score them independently. So don't say that because I don't know the hypothesis, I cannot proceed with the experiment. Proceed with it. I put these features here are scored independent of the other. You can follow the procedures, but you go on and get the results correct. It is correct. Or else we shall not say that since the procedures are correct, I'm not going to read through the observations. Everything is independent of the other. Now, observations, what do you put under observations? Observations, what have you seen? Or what are the results? What are the results? For instance, in this one here, how will I rate my observations? I will just say, in test tube 1, the rate of reaction was slow. In test tube 2, there was a rapid rate of, actually there was a very rapid rate of reaction. In test tube 3, the reaction rate was moderate, Now, what have I done? I have recorded my results. I have recorded my procedures. Do I have to put them in a table? Maybe yes, maybe no. But can they still be written without a table? They can still be written without a table. You just outline them. Like the one mentioning them, you just say observations or results. Then below it, first bullet, in test tube 1, rate of reaction was slow. Another bullet, in test tube 2, the rate of reaction was very rapid, full stop. Another bullet, in test tube 3, the rate of reaction was moderate. What have I done? I have presented my results. Then I now go to explanation. I now write explanation on my report. Now, what is explanation? Explanation is basically interpretation of your results. It is basically interpretation of your results. That is the explanation. How do you interpret your results? How do you interpret them? So under that, if I'm writing, I will just say explanation of results. Bullet 1, in the test tube 1, there was a slow breakdown of hydrogen peroxide. I have interpreted my results. There was a slow breakdown of hydrogen peroxide because the pH was acidic. Full stop. In test tube 2, there was rapid breakdown of hydrogen peroxide by catalase enzyme because the conditions were alkaline. And catalase enzyme works best under alkaline conditions. Stop. In bullet number 3, I will say in test tube 3, there was moderate breakdown of hydrogen peroxide because catalase enzyme works moderately in neutral conditions. I will have explained my results. That's what they call the explanation of results. Actually, explanation of results is the interpretation of the results. How do you interpret them? And partly maybe also how do you explain them? Then the last thing on the report is the conclusion or recommendation. Now, how do you conclude? By conclusion, you first look at your results. Then you go and read your hypothesis. Look at two things. Look at your results. Go and read your hypothesis. Then you make a conclusion based on the two. So the conclusion is based on the results and the hypothesis. Now, in this case for me, how would I conclude? How would I conclude? I'll look at my results. My results are saying catalase enzyme works best under neutral, so under alkaline conditions. Then I will go and read my hypothesis. I had hypothesized that catalase enzyme works best under specific pH. Now, I'll now come and make a conclusion based on that. Now, I will conclude by saying that catalase, therefore, in conclusion, catalase enzyme works best under alkaline pH. I have concluded. How have I been able to conclude? Looked at my results, looked at my hypothesis. So that's how you conclude. Now together, that's how you conclude. And that is how you present your results in a biology practical. In a biology practical. Okay, so I will welcome only 2 questions. Then after that, in 5 minutes, I wrap up number 2. Then we call it a day. So are there any questions? Someone is saying, should the apparatus be written in a sentence? It doesn't matter. Write them in any way. Write them in any way that you think. Someone is saying, can you send us the link to revisit? Yes, this meeting is being recorded, and the link to the recording will be shared from where you picked the invitation. So they will post there the links. Okay. Ushin is saying, do we need to conclude with variables included? No, you don't conclude with variables included. You just conclude with the results and together with your hypothesis. Okay. Sulaiman is appreciating here. Thank you. Thank you, Sulaiman. Chisana, okay. Sir, is there a need for a setup? Now, is there a need for a setup? Now, a setup is basically actually the procedures. A setup are the procedures. Setup are the procedures. So if you feel like what you have written is not enough, if you feel that it is not enough, then you can back up your procedures with the drawings of the setup. But the setup will together be scored as procedures. The setup will together be scored as procedures. Okay. My battery is about to die and my power cable is far from me. But let me see if it can push us. Okay. But if you fail to read the procedures all, if you fail to read the procedures all, you'll score 0 on the procedures. If you fail to read the procedures, you'll score 0 on the procedures. But please, as we have seen, it is very easy to read these procedures. It is very easy. If you can come up with the experimental setup, then just interpret to us how you came up with that experimental setup. Just actually, the procedures are just basically steps of how you came up with the experimental setup. So it is very easy to come up with the procedures. Okay. Then, do we include the risks or errors and the mitigations? Now, the risks and the errors are for physics and chemistry. I repeat, risks and errors are for physics and chemistry. We don't have errors and risks in biology. For us in biology, this is the report that we follow. This is the report that we follow. This one, chemistry, they have theirs with errors and risks. Physics, they also have theirs. For us in biology, this is what we follow. So we don't have them. Okay. Do we include the apparatus in the report? Okay. How many questions I examined? I think this one came late. About the practical, we have 2 questions. We have 2 questions. Okay. Do we include the introduction? This one also came late. Now, for us, we don't actually to know how much to write. You just follow this. You follow this. You write the aim, hypothesis, etc. There is no need of the introduction. There is no need of introduction. Okay. Then, lastly, someone is asking your contact, sir. Explanation about the item number 2. Okay, you'll get the contacts. Now let us go now very quickly to number 2. Okay. Now, number 2. In just 5 minutes, I'll be done with this number 2. Just 5 minutes. Now, number 2 is simple. Number 2 is simple. You just flow with the tasks. There is no technicality there involved. Part A, do this, you do it. Part B, do this, you do it. Part C, draw and label, you draw and label. So part 2 is very easy. It is not technical at all. Actually, number 2 is put there for everyone to enjoy. After suffering, after struggling with number 1, then you go and have a smile on number 2. So number 2 comes from these areas. So you take note of them. Number 2 comes from these areas. Take note of them. It can come from insects. It can come from leaves. It can come from flowers. It can come from stems. It can come from teeth. It can come from vertebrate bones. It can come from roots. It can come from fruits. So these are the areas where number 2 can come from. That's where number 2 can come from. Okay. Then still, which tense should procedures be? People are still asking on the tense. Now, the one asking about the tense, I have said, the tense does not matter. The tense does not matter. The tense does not matter. Use any tense that you want. Use any tense that you want. Chibuka, they are saying, what about title? We don't have the title. For us, we have the aim. Just stick to the report, the report format that I have given you. Osira James is asking, when is our theory seminar, sir? Theory was yesterday. And it was presented by a colleague of mine. I think Mr. Kaziba will also, later they will share the presentation for the theory. Okay. Now, I hope now you have recorded what is required. So the areas from where number 2 comes from. Now, that is an example, a sample of number 2. So you can see how easy they are. You can see how easy they are. So you can be reading through it. Let me try to connect, then we conclude, because I'm seeing the battery is warning. So you try to read through that.
Teacher Aka?
Yes, Mr. Kaziba.
Okay.
I was trying to reach for the power cable, which I have done.
Okay.
So now, when we look at that item, ideally, is there anything hard there? You just read the task. For example, part A, they are saying, as a student of biology, identify with reasons the potential vector, highlighting how it is adapted to life as a vector. Now, supposing they have given us a housefly, we have a termite, then we have a cockroach, and any other insect. Then they are saying, which of those is the vector? So you look at them. If you look at them, you may realize that actually it is the insect, sorry, it is the housefly which is the culprit. So how is it a problem? Or how do you think, or how have you zeroed down at the housefly? Then now things like it is hairy. Yes, it can carry germs. It has a proboscis for sucking on liquids, on fluid foods like the feces, which would be having the germs that cause cholera. Part B, construct the dichotomous key. You just construct the dichotomous key. I'm sure your teachers must have taken you through the steps of constructing a dichotomous key. Then part C, draw and label the hind limb of maybe say a cockroach. Then what do? You draw and label the hind limb of a cockroach. So basically, that is number 2. There is no technicality there. Don't say that, is it a report? No, it is not a report. You just follow the tasks one at a time and you answer them like that. So that is item number 2. And there is nothing so technical about it. I think now we have come to the end of this. I've come to the end of this. So people were asking for my contacts. Those are my contacts. Yes, I normally get in messages in WhatsApp, but if you're asking something on WhatsApp, just be specific on how you want me to help you, because I receive very many messages. Be specific. Don't say hi. Don't say hello and you wait for it to be responded to. I don't respond to that. If there is a problem, maybe you need assistance, or maybe say hypothesis, just type the message clear and say, excuse me, sir, I did not understand what a hypothesis is. As simple as that. Then I will respond. Then, yeah, I think basically it is that. So I'm going to respond some questions. Then we close the session at exactly 6:30. At exactly 6:30. Okay, so what are the questions? What are the examples under item 2? I think you've seen an example under item 2. Okay. Then we request that you take us back to element of construct 1 and examinable areas. Hey, now, element of construct 1, those ones who came late, the examinable areas were only 4. Food tests, soil experiments, enzyme activity, and osmosis. Only 4. There were only 4. Food tests, enzyme activities, soil experiments, and the osmosis. Okay. What is the scoring guide for item number 2? Now, you don't have to mind about the scoring guide of item number 2. We just base on what you have written. We base on what you have written and we score you as you have written it. We base on what? If you say that maybe the specimen, that, for example, if you look at that scenario of ours, if you say that the specimen was a housefly, and you're saying because it has a hairy body, now we shall score that one. Hairy body, correct. Like that. So we score them as you rate them. Like I said, item number 2, it doesn't have a lot of technicalities. Okay. Okay. Bishops, they're asking, are feathers examined? Feathers are not part of the syllabus. They are not part of the syllabus. Okay. Okay, other people are appreciating. Thank you for appreciating. I'm very grateful. And I take honor to God. You know, when I was coming for this meeting, I first had to make sure I prepare myself and I pray. I prayed for God to bless the work of my hands, that everything I teach becomes simple to you. So I take the honor back to God. Okay, 1 verbal question. So 2 verbal questions, then we close. Davis Murunji, Davis Murungi.
All right. Thank you so much, Mr. Kugonza. We really do appreciate for the work well done. Mine is actually a request. If it's possible, could you please share the scoring guide for the first item? And then maybe even for the theory paper, so that we can be able to relate what we have seen with the scoring guide. Thank you, sir.
Okay, now there is a presentation. Okay, you'll WhatsApp me. You'll WhatsApp me. I'll see what I can share with you. Send me a message on WhatsApp. See what I can share with you. Then Ushindi SS. Ushindi. Ushindi, we can't hear anything. Solid Rock. Solid Rock.
Yes. So, well, I want to know where the skeleton system lies because you have not seen it anywhere.
Okay. Yeah. The skeletal system, look at here. I said vertebral bones. Vertebral bones. So it lies under the vertebrae, lies under the vertebral bones. That's where the skeletal system lies. Okay, Destiny SS.
Is now how to identify this. Yes.
We are hearing now from Destiny SS. Destiny SS.
Sir, thank you for the presentation, but our question is, we didn't notice it very well when you're writing the procedures in the box of food testing. Do you have to say I added, or how do you have to handle that such thing?
Well, what I said is that we don't have restrictions on how you should rate your procedures. We don't have restrictions. If you want to say I added, it is okay. They are procedures. If you say add, it is okay. They are your procedures. If you say I will add, it's still okay, as long as they are procedures. It doesn't matter the tense you use or the language you use. Then lastly, I know at the end of the day we have to go. Lastly, St. Luke with DSS.
Yeah, my question is about the variables. Like if the experiment is only having one variable or two, then how can you conclude with the variables? Do you write them like a dependent variable or you just leave them like that?
Now for the variables, you just write them the way they are. You just write them the way they are. If it is only one, you write it one. If there are two, you write all of them. If there are five, you write all of them. You just write them the way they are. For instance, our soil experiment, if you think the variables are only two, volume of water used, volume of soil used, that's how you write them. Variables, you say the first one, volume of water used, full stop. The second one, volume of soil used, full stop, just like that. Don't commit to say controlled for variables or independent variables because you may commit wrongly. Only commit if you're sure that you are correct. Okay, so Mr. Kaziba, I think we've come to the end of today's session. Over to you, please.
Thank you so much, Teacher Arthur, for the wonderful presentation. We are really very grateful for the service we have offered. Thank you so much. I want also to thank the teachers that have been on this call. Thank you so much. We shall continue with the program tomorrow. Tomorrow we shall have ICT and we shall mainly concentrate on the websites. We shall develop the different websites using other, because we didn't complete. But I also want to let you know that we shall be able to share the recording for this session before 9 p.m. today. So just check on the YouTube channel. You'll be able to find it there. But also I want Teacher Arthur, maybe can you give some concluding remarks before Mr. Ronald comes in? Any concluding remarks for the students?
Okay, thank you, Mr. Kaziba. What I can say to the students is that they shouldn't be scared. These things are very easy and they are doable. And they shouldn't have a lot of restrictions on themselves. Like, for example, the questions I'm hearing that which tense should I use? How should I write this? The new curriculum came for you. You just have to express yourself. You express yourself. And for us, when the examiners are scoring you, they're just scoring the achievement of the competences. What are you able to do? Not how you have written or what you have written, but we just read from whatever you have written, then you're able to make a conclusion of your achievements. So just express yourself, don't have restrictions, and don't panic. When you read the task, just think through it and write. So you don't have to be scared. These things are doable. You'll do them if you'll do them. Maybe I talked about catalase enzyme, and some of you were very scared that you have never heard of catalase enzyme. Still, we still have time. You can engage your teachers to now have maybe take you through that catalase enzyme, maybe before you prepare for the exams. In that when you find it there, you're not caught by surprise. Otherwise, don't be scared. These things are easy and you'll be able to do them. Over to you, Mr. Kaziba.
Yes, thank you so much, Teacher Arthur. Teacher, let me call on Mr. Ronald to... Mr. Ronald, are you in position to talk? Okay, good.
Mr. Kaziba. Good evening, everyone. I want to thank Teacher Arthur for leading us through today. We are all happy to be visiting St. Mary's College Subi Biology Laboratory and learn from there. And that's what we mean by closing the learning gap. At least all of us this afternoon have been into that one place, that one laboratory, and we've learned what we might have missed. Someone was asking, where do we find the e-learning platform? And I just typed in the chat to say, when you Google holistic e-learning platform, you will select what you want to check, but the YouTube channel will be clear to you, and most of the work that has been happening since COVID is right there. I want to thank all the teachers who have been on this call today and for all the days. We are 2 weeks into this activity, and this is very good. We've gained a lot, we've learned a lot, and hope for the candidates. You are better candidates, you're better people, and you're going to attempt the mock exam well. I want to thank Mr. Kaziba and your team and all the other people behind this program for helping us as the Ministry of Education to close this learning gap. And indeed, we are really closing the learning gap because we are all learning together. With that, I want to wish everybody a good evening, and let us catch up again tomorrow. Good evening. Thank you.